Hi guys, welcome to section 1.3b, distance and midpoints. I know yesterday we talked about Pythag and distance formula. We're going to talk about number line here first of all, and kind of mix and match, but really midpoint's going to be our main focus. As always, don't get stressed. If there's something that's not clear, we'll talk about it when I get back. I'm sorry I can't be there, but that's all right. So first of all, if we're talking about number lines, notice these first couple examples are just straight up number lines, not a coordinate plane. So we're working in just the one dimension. So if we're going to find distance between 2 points, like say the distance between B and E, my guess is that a lot of you would just count on the number line. There is a technical thing that you're actually doing, and it has to do with absolute value. So you could, I'm going to put or count. It's kind of one of those things, you know, if it works for you, why mess with it? But really, what we're doing is we're taking the absolute value of the difference of the coordinates. The absolute value of the distance of the coordinates. So the absolute value of b minus a, or the absolute value of a minus b. So if this is point A and this is point B, we're subtracting. Now the absolute value means we don't care what order. So over here, you might have counted to figure out the distance, for example, 1 is 8. Or if we're going to follow that formula, you might say we would do the absolute value of the coordinate of B minus the coordinate of E. Or, if you didn't care about that, you could go the other way. The coordinate of E minus the coordinate of B. Notice either way it goes, you get an 8 or a -8, but of course everybody knows what happens when you take the absolute value. We just care about how far it is from 0, basically, so 8 units. Again, some of you might just count that out. If we're talking about midpoint, midpoint is halfway, right? So it stands to reason if we're going to find halfway, we're going to have to divide by 2. So midpoint is the two coordinates, a plus b, divided by 2. So again, here's a on my little number line. There's b on my little number line. The midpoint is exactly halfway. We'll use a capital M to signify that. And that betweenness of points, remember, the point was somewhere between the other two. This is a definitive halfway point. This is the midpoint. So for example number 2, if we're going to find the midpoint of BF, point B is down here at -6. Point F is down here at 5. We add those guys up and divide by 2. So -6 plus 5 is -1/2. So -1/2 or -0.5. So right here, I'm going to use a different color. Right here is the midpoint of BF. Some of you might work your way in and kind of count your way to the middle. So I could ask you the midpoint of CD. That one is really easy on that number line because C and D are 2 units apart, so the midpoint would be -3. But if we're being technical, we'd say -4 plus -2, divide that by 2, and we'd end up with a -3. All right, no problem on those. Number lines are easy, and so much of it is common sense because you learned it when you were younger. Midpoint on a coordinate plane has the same concept. So notice we're working with 2 ordered pairs, x1, y1, and x2, y2. Same kind of ordered pairs that we were working with when we found distance formula. Here's the thing, if we found distance formula, we'd know how far apart those ordered pairs are, but we'd still have to do some extra work to find the halfway point because the line probably has a slope to it. So be careful on that one. So let's go to the formula. The formula for midpoint, notice this time I did midpoint, and then in these little parentheses right here, I did in terms of xy. So my answer is going to be an ordered pair. So for the x coordinate of my midpoint, I add up the two x's and divide by 2, comma. The y coordinate of my midpoint, I add up the two y's and divide by 2. So x1 plus x2 over 2, y1 plus y2 over 2. We're really finding the average, which is what we were doing for midpoint on a number line as well. We only had one coordinate to work with. So go ahead and sketch these 2 points. The midpoint of A is at 5, 2. Label it with an A. Point B is at negative 3, 4. Label it with a B. Connect those guys. Now you might try to eyeball your way to a midpoint, and maybe you'd get it. That's really great, but sometimes it doesn't work that way. When you get to the point where you don't even need to see the graph, then you're relying strictly on the formula. Sometimes it helps to see it. So if we're going to find the midpoint of these two ordered pairs, I'm going to call A my x1, y1. I'm going to call B my x2, y2. It doesn't matter which one is which, you'll still get the same ordered pairs. So if we're going to find the midpoint, I'm going to put this in a big parenthesis. It's 2 problems in one parenthesis, my x coordinate and my y coordinate. The x coordinate comes from the average of my x's. So x1 plus x2 would be 5 plus negative 3 over 2. And probably you might finish that one or write out if we do finish that. What's 5 plus negative 3? 2 over 2 gives me a 1. So I'm going to say for my y coordinate of my midpoint, I'm going to take the averages of my y's. So my y1 is 2 plus 4. Divide that by 2, so that would be 6 divided by 2. So my midpoint should be at over 1, up 1, 2, 3. And go ahead and put that M on your segment. So you might have had a great guess that it was going to be at 1, 3. It doesn't always fall on a nice, neat grid mark, so we never really know. So going along with that is a segment bisector. So bisector means that it cuts it in half. So really midpoint and bisectors go together. They lend to each other. A bisector itself is, there it is, any segment, line, or plane that intersects a segment at its midpoint. Therefore, we're talking about segment bisectors. So a segment gets bisected. It gets cut in half. That halfway point is its midpoint. So in this example up here that we labeled that M, I could put another segment, and it doesn't have to be nice and neat and perpendicular. This CD that I just added would be a segment bisector because it bisects or it goes through AB at its midpoint. Notice I tried to draw it a little bit off so that it doesn't look like CD gets bisected. Definitely shorter, CM is smaller than MD, but AB gets bisected. So segment bisector, it's an important term, probably highlighter worthy. I'll use that term bisector a lot. All right, so let's do a couple examples. Find the distance between the points. Let's just do B. This one you might count, this one you might common sense your way through it. If we're going to use the formula, distance we subtract, midpoint we add. So make sure you notice that distinction. I am not going to make a number line that goes from 140 on the positive side to negative 200 on the negative side. So I'm just going to use my absolute value. Doesn't matter which way we go, but distance means we subtract. Think about the distance formula. We subtract inside each parenthesis. So 140 minus that negative 200. So our distance is going to be the absolute value of 340 or just 340. So 340 units between them. You probably could figure that out in your head. I know. Let's skip 3A. Let's run over to 4A this time. Find the midpoint of each segment. So midpoint means we're going to add and divide by 2. Or in other words, we're going to take the average. So if we want to know the midpoint, I've got a segment that starts at -12, it ends at 16. Think number line because I'm not giving you ordered pairs. So if we're going to do that, we're going to take our two coordinates and we're going to add them together. Pretend that's a good number line. We're going to add them together and divide by 2. So -12 plus 16 over 2. 4 halves is the same as 2. So right here at 2 would be my midpoint. It makes sense, right? It's got to be slightly to the right of 0. So far, so good. Hopefully I'm not talking too fast. Hit pause if we need to. Let's find the coordinates of each midpoint. Let's just do example A, 5A. Again, I skip examples. Feel free to go back and fill the other ones in. So -8, 6 is one of my ordered pairs. -14, 12 is my other ordered pair. Those numbers are relatively large. I don't want to graph that. If you need to, go ahead. But if I'm going to find the coordinates of the midpoint, please watch carefully on this one because the next problem that we do, number 6, is a problem in which we've got a different unknown. So I want to make sure that you see what we're talking about. So we're looking for the midpoint. It's going to be an ordered pair, x, y. If we start with ordered pairs, you end with ordered pairs. So if you look at that other, here's going to be my x, and here's going to be my y. If you look at the formula that we did, remember we said one ordered pair is x1, y1. One ordered pair is x2, y2. So how do you find the x coordinate of the midpoint? We find the average of the x's, add up the two x's, and divide by 2. So 8 plus -14 is -6, divided by 2 gives us a -3. To find the coordinates of the y for the midpoint, we take the y1 plus y2, so -6 plus 12, divide that by 2. So -6 plus 12 is 6 divided by 2. So -3, 3 will be my midpoint. Everybody okay with that one? This is a lot of formula use. Hopefully you've seen this before. I didn't rewrite that formula. If you need to rewrite the formula or on the top of your homework paper, write the formulas so you can refer to them. The more you see them and use them, the better you'll get with them. All right, let's look at practice number 6. Let's just do A again. So the directions for 6 say to find the coordinates of the endpoint if the midpoint is known. So this is interesting. It says in 6A, D, if E is at -6, 4, is the midpoint of DF, and F has coordinates of -5, -3. So let's do a little diagram here. What is the midpoint? It says E is the midpoint of DF, right? So DF has to be the segment. E is in the center, and we know E, -6, 4. Do we know the coordinates of D? We don't, do we? Do we know the coordinates of F? F has coordinates of -5, -3. I'm very much a diagram person. Now I know that I drew a horizontal line. It doesn't really lend itself. If you want to use a graph, go ahead. But I do want to see your math and using your formula. So here's our formula. Midpoint xy, x1 plus y, oh, nope, x1 plus x2 divided by 2. Caught that just in time. y1 plus y2 divided by 2. And you know how I keep writing x up here and y up here? I did that on purpose for a problem just like this. So if I'm going to find the midpoint, I would make my big parentheses and I would say something like, well, to find the midpoint, I add up the two endpoint x's and divide by 2. Well, in this case, my endpoint x's are x and -5. So when I put that into my formula, the only thing I can do is add up what I know and divide by 2. However, I could write a number up above there like I wrote x the last time because we know the midpoint value of x. It's -6. So if I do that, how can I solve to figure out what x is? If I do x plus -5 equals 2, I get an answer of -6. Do you see an equation coming on here? That is equal to that. That's a sideways equal sign. So I would set up an x plus -5 over 2 equals -6, and then we can solve this. So I use my two endpoints, add them together, and divide by 2. But now I know what the answer has to be. So my strategy would be to get rid of that fraction 2, multiply by 2 on both sides. X plus -5 equals -12. And then I'm going to add 5 on both sides. So I'm thinking that my x value of my endpoint is -7. So now if we can follow the same pattern, we're going to do the same thing for the y's. So my two endpoints added together and divided by 2. So my two y endpoints are y and -3. So y plus -3 divided by 2. Only now I know what the answer's got to come out to, right? Right here, that's got to equal 4. I'm going to write that little 4 above there. So if I know that I did the math problem y plus -3 over 2, it's going to give me a 4. I can use that to set up an equation. So I'm going to do the same thing. I'm going to say y plus -3 over 2. That's got to be equal to 4. And then I'm going to use the same strategy to solve. I'm going to multiply by 2. So y plus -3 equals 8. And I'm going to go ahead and add 3. So it looks to me like my y coordinate is 11. If this were a quiz or a test and I said write your answer on the answer line, what are the coordinates of that endpoint? You would tell me it would be -7, 11. Those ones are tricky problems. Hopefully you caught that pattern as we went through them. If not, we'll talk more about those tomorrow. I promise we will practice those because those are really good ones. But you use the formula to your advantage. All right? And last but not least, I feel like we could set this up. It says, what's the measure of PR? So I want to know the whole thing. If Q is the midpoint of PR. So Q is the midpoint. When we did section 1, 2, we had the betweenness of points, and Q was somewhere in the middle, but now we know that Q is the midpoint. So if I were to mark my diagram, I would actually put little congruent dashes, right? Because if Q is the midpoint, that means that PQ is congruent to QR. Notice my geometric statement. You guys love writing those. So if I write out my geometric statement, and yes, you have to write that. One of the reasons that I want you to write that is because I want you to be thinking about, are the things adding up to give you the whole thing? Or are the two parts congruent to each other? So if PQ is congruent to QR, I can substitute the values in. What's the value of PQ? 4x minus 5. When we're doing a math problem, instead of the congruent sign, what do we use? Equals, right? And then my value to substitute for QR is 11 plus 2x. Does everybody feel confident solving that one? We don't really necessarily have to do that. Finish that guy off. Make sure that you've got it. I believe 8, maybe, something in that range. So that's wrapping up section 1-3B. It is Classic Joke Wednesday, and I didn't even forget. So don't be a shout out. Are you guys ready for this one? Maybe I shouldn't tell you the answer. What did the hat say to the tie? That's a good one. Hat said, you like my clip art, by the way. Hat said to the tie, you hang around here. I'll go ahead. I know you're laughing right now. All right, so your assignment. Random assortment of stuff. I've got the wrong date up there, which is kind of a problem. Excuse me, today's 9/13. Pages 31 and 32, 14 to 18, 34 to 44, and then 48 and 50, the evens. Show your work when needed. Please use your stuff to your advantage. Cross that out. We've got a quiz on Friday on sections 1 through 3, which you already knew, and tomorrow we'll do some reviewing. And please check Skyward for your grades. Have a great day. I'll see you tomorrow. No stress. We'll clean things up if we need to. Talk to you later.